All right, so I said I wanted to go through these 4 remaining problems on this page, and we're going to find that we don't have time to do 145. It's just too big to do in a video. But I would like to take a look at 125 here. So when you're doing problem 125, notice you have a 0.157 gram sample, and you produce 2.13 grams of carbon dioxide. Now, that carbon in that carbon dioxide comes from the sample. The oxygen probably comes from the air, maybe some of it from the sample, but you're not sure. But we do know that all of the carbon comes from the carbon dioxide. And we want to turn that into moles. And there's 1 carbon in every 1 carbon dioxide, and that's going to give us the moles of carbon. And from there, we can then multiply by the molar mass of carbon. And that'll tell us that we're going to end up with 0.05809 grams of carbon in our sample. We're going to use that to then do our empirical formula calculation. And we're going to repeat the same thing for hydrogen, except when you're doing hydrogen, you have to use the different sample. You're going to have to use water's molar mass, which will be 18. And notice there are 2 hydrogen in water. Okay? And then multiply by the molar mass. You're going to end up with 0.03 10 grams of it. I might be wrong on that number. When you get to the end there, to find the percentage, you do need to divide by the sample mass. And this is going to be then the 2 and then the 18 and then the 0.157. And that's going to give you 37% carbon and 2.21% hydrogen. When you do the same type of calculation for the nitrogen, notice you have a different starting amount, different mass sample, but you're still going to end up with 18.39% nitrogen. Now, how do we deal with oxygen in a problem like this? Well, the oxygen that gets produced from burning could come from the air, could come from the sample, but we do know that our total percent needs to end up to be 100. And so if we subtract the different percentages from carbon, hydrogen, and nitrogen, we're going to end up with about 42.4% oxygen. Now, some of my decimals might be a little bit off, but it's not going to make a difference in the end. When you do this, then remember to do empirical formula. You take the percent. This is carbon. This is going to be hydrogen, nitrogen, oxygen. Divide by each molar mass. That's going to give us our mole ratios. Moles of carbon to moles of hydrogen to moles of nitrogen, and finally oxygen. Then the next step is to divide by the smallest, which is 131. And that gives us a ratio. Now, it's not actually going to be a whole number ratio. And I want you to notice that it's like pretty close to 1/3 or 2/3 in each of these. And so you should multiply by 3. If you multiply all of these by 3, you're going to end up with 6 7 carbons, 5 hydrogens, 3 nitrogens, and 6 oxygens. And so that's how you solve this type of problem going through empirical formulas.